Hello everyone, and welcome back to another GIS lecture video. And in this lecture video, I want to hammer home this idea of interactions with matter by talking about three things. First, I want to hammer home this idea of these three interaction types. Then I want to hammer home this idea of percent reflectance and show why it's so important. And then finally, I want to talk about these three interactions being dependent on wavelength and a couple of key properties about the object itself. So let's go ahead and give ourselves a little bit of room here. And we're just going to be extending the same concept in the previous video, talking about interactions with matter. Okay. And so the first thing that I want to do is I want to talk about the atmosphere in relation to our interactions here, and talk about what actually is being measured. At the sensor. Right, so in our previous video, we sort of made this simplistic model where we had the sun producing some specifically red light. The red light was hitting, in the case of our example, a leaf. Part of that was being reflected off and reaching the sensor. Right, so what I want to do is I want to make a more complicated and slightly more realistic example. Right, so let's imagine if instead of just the leaf, we're going to draw the leaf again, but we're going to have our sensor. Right, this is our satellite over here. Right, so we have our sensor. We have the sun. We have matter. Right. So this is the exact same diagram we drew before. But right, this is Earth. Right, these are satellites. There's space between the sun and matter, and there's space between the sensor and matter. Now, what's in that space, right? At least on Earth anyway, what's in that space is atmosphere. Right? Atmosphere. And we didn't talk about atmosphere last time. Now, you could argue, if you're actually interested in studying the atmosphere, which some people are, that the atmosphere itself is matter, and you would be right. Right? This is also matter. And so what that means is the same concepts that we talked about with our leaf last time apply to the atmosphere as well. But if what we're interested in instead is this leaf, or the matter on the ground, right, we have to realize that this atmosphere is here as well. So let's go ahead and look at what this does to how this complicates our example, and talk about what is actually being measured at the sensor. Okay? So we have ER, I'm going to label it again. Right, this is our electromagnetic radiation. Right, hits the atmosphere, goes through the atmosphere, hits the matter, reflects off the matter, hits the sensor. Right, this is the pathway that we talked about in the previous video. But, okay, so one source, right, sources wrote just about the second time. Right, sources of ER at the sensor. Right. Well, the first source, the first thing we're getting is the surface reflectance, right? What is being reflected off of the ground. Right. This is the thing we think we have, right? So this line here, right? This is what we want, right? Or what we think we have, right? The energy that's being reflected off the matter to the satellite, right? That's pathway 1. Pathway 2, I'm going to try and do this with a dotted line, something like this, right? We have energy that comes off. Right, this is also ER. I'm just highlighting that it's different. I'm making it dotted so that you see that it's a different type. Right, it hits the atmosphere, right? But again, atmosphere is also matter. So atmosphere has those same 3 interaction types, right? In this case here, right, we were just assuming that the atmosphere was transmissive, right? That the energy is being transmitted through. But it doesn't have to be, right? It can be absorbed, transmitted, or reflected. So another thing that can happen, right, is that energy comes from the sun, hits the top of the atmosphere, is reflected off, and hits the sensor, right? So the second source, right, the second thing that's actually being measured by the sensor is atmospheric reflectance. Right? So this dotted line here, right, this is the energy that is being reflected off of the atmosphere before reaching the thing we want, bouncing and hitting the sensor. Right? So for now we've got 2 sources. We have the thing we think, the thing we want, the thing we think we have, plus whatever is bouncing off the top of the atmosphere. And then there's another source. I'm going to do this one in sort of long dashed lines. Okay. Actually, let's make this slightly more obvious that it's something different, right? So with the atmosphere, what you have to remember is the atmosphere is, 1, not homogeneous, right? It's got particles in different concentrations, all depending on density. It has all kinds of things happening. So let's say we have some energy being emitted going this direction. Right, it hits the atmosphere, but because there's all these particles in the atmosphere, right, it's being reflected, but that reflection is actually bouncing around, right? Think of it like when you're at a carnival or an arcade and you have that game where you put the ball on the top and it bounces off all the pegs, right? The atmosphere is kind of like that. So we could have some energy coming over here being literally bounced around in the atmosphere before finally escaping in a direction that hits the sensor, right? So this dashed line here was never even part of the original energy that was coming towards the matter, right? We have the stuff that hit the matter and bounced off, which is what we want. We have the stuff that was on its way to the matter, but bounced off the top of the atmosphere instead. But then we also have this crazy jagged line that we don't even want. It was never part of the energy that was coming towards the sensor, right? This dashed jagged line here, I'm going to scroll down and give us just a little bit more room. Right, this dashed jagged line is called scattering. Okay, so what's actually being measured at the sensor is the energy we think we want, which is what's being bounced off of the thing we're interested in. Some energy that is being bounced off the top of the atmosphere before it even reaches the thing we're interested in. That's called atmospheric reflection. And then we have random energy, right, random radiation that was meant somewhere else, that was being bounced around in the atmosphere, that ended up hitting the sensor. Right, so those are the three major components of what's actually being measured at the sensor. Okay? So hopefully that makes sense, this idea that we have these three different sources. What hit the matter, what hit the atmosphere, and what was bouncing around. That are all three contributing to what is actually being measured at the sensor. Hopefully that makes sense, and as always, if you have any questions, please reach out. Thank you.